this video, we'll be exploring a fascinating topic in cognitive neuroscience, how memory systems interact and what happens when parts of the brain, like the hippocampus, are damaged.
Let's start with a classic view. Memory is often divided into short-term memory and long-term memory. Short-term memory is like the brain scratch pad, holding information temporarily. Long-term memory stores knowledge and experiences over time.
But here's the question. Can memory still function well, even improve, when the hippocampus, a key memory structure, is damaged?
To dive in, let's define a few key concepts. Short-term memory holds small amounts of information for brief periods. Long-term memory involves more permanent storage. The hippocampus, located in the medial temporal lobe, plays a vital role in forming and linking new memories.
Traditionally, it is thought that the hippocampus helps integrate short-term memory and long-term memory, but this study by Race and colleagues from 2015 tests whether prior knowledge stored in long-term memory can still support short-term memory without a fully functioning hippocampus.
The researchers studied patients with medial temporal lobe amnesia, meaning they had hippocampal damage. They wanted to see whether short-term memory and long-term memory integration depends on the hippocampus and whether this interaction differs between verbal and visuospatial information.
In the first experiment, they explored the sentence superiority effect. This is when remembering words is easier if they form a meaningful sentence.
Surprisingly, patients with hippocampal damage still performed better when the words formed sentences, suggesting that verbal short-term memory can be boosted by semantic long-term memory knowledge, even without a fully functional hippocampus.
In the second experiment, they looked at the visual spatial bootstrapping effect, where number recall improves when digits are shown in a familiar keypad layout.
Again, patients showed improved performance, indicating they were able to use visuospatial long-term memory to support short-term memory despite hippocampal damage.
So what does this mean? The study showed that both semantic and visual spatial knowledge can enhance short-term memory, and, importantly, these enhancements can occur independently of the hippocampus.
This suggests that the brain has multiple memory systems that can work together or compensate for one another, especially when one part, like the hippocampus, is impaired.
Memory is more adaptable than we often think. Prior knowledge stored in long-term memory can still boost short-term memory performance, even when key brain areas are damaged.